Welcome to Cloud on Air, live webinars from Google Cloud. We host these webinars every Tuesday. My name is Matt Duffler, and today we'll be talking about automated Canary Analysis. Joining me are Stephen Kim from Google, Michael Graff and Chris Sandin from Netflix, and they'll introduce themselves as they come up to speak. You can ask questions anytime on the platform, and we have Googlers on standby to answer your questions. So let's get started. We're going to start with a pretty high-level overview of CI/CD, continuous integration and continuous delivery. Then we'll dive into exactly what a Canary release is. We'll talk in a fair amount of detail about Kayenta itself and how it integrates with Spinnaker. Then we'll do a demo. Then Chris will come back up and he'll talk about different practical considerations to keep in mind as you start to employ automated Canary analysis in your own release pipelines. Then Stephen will come up and he's going to go through the various steps of getting Spinnaker installed, just kind of a pathway to follow. Install Spinnaker, enable Kayenta, configure everything, what kind of metrics to look for, where to find the various community members involved, and then we'll do some Q&A. So get your questions in early, and we'll tackle as many as we can at the end of the presentation. So this is a fairly typical development team's workflow. You can see it's rendered as a loop. The idea is that developers are always making changes. They're always pushing changes. The changes are constantly integrated into the main branch of a shared source code repository. All of those changes are subjected to automated tests, and ultimately builds are automatically produced that can be released into production at will. You want to avoid the scenario where you plan releases over a period of many months and it's a big risky operation. The idea is to automate everything from I make a change in my source code, I push it, go through all the various test suites, automatically produce a build, get it in a state that it's ready to be deployed into production at any time with the push of a button. We don't want this to be a big risky thing. It should be boring and safe, and you should be able to do this at any time. Keep in mind when we talk about releases throughout this presentation, we're really talking about any production change. It can be a code change, it can be a change to the configuration of the application, it can even be changes to the infrastructure underlying the application itself. With this in mind, the primary goal of Spinnaker is to make releases boring, safe, and repeatable. Canary releases are just one tool in the Spinnaker toolbox to make releases safer. As you hear all of us talk about canaries, and we're going to show all the different configurations, and we may here and there describe it as testing, keep in mind it really is not in any way a replacement for other forms of testing. As you build out your release workflow for your shop, this is not a replacement for unit testing, integration testing, capacity and load testing, or any other form of automated tests. It's just an additional thing that you can employ with the goal of increasing your confidence that a new release is safe to fully deploy into production without slowing down your development workflow. Next up, Chris is going to come up and he's going to describe exactly what a Canary release is.
Great. Thank you, Matt. So to expand on this idea of a Canary release further, it is really a deployment pattern or release process where a new change, whether it's code, configuration, as Matt alluded to, that is deployed into production, but for a subset of our users. And so it gets its terminology or its name from the coal mining industry, where miners would take a canary bird into the coal mine with them, and these birds would act as an early warning signal to the buildup of toxic gases. This would give the coal miners a sense of safety as they worked in the mine. In a similar way, a Canary release can help make your deployment safer by reducing the impact that any one change can have on your environment. And this is because the Canary, as you release it, is going to serve a small subset of your traffic. If something catastrophic happens or goes wrong, it'll only impact a small percentage of your users. And so this can lead to safer deployments by reducing that blast radius. Now, to emphasize what Matt had said, a Canary release is not a form of testing, or is not to replace testing in and of itself. It's just another tool towards a safer deployment and augments or enhances the CI/CD workflow. Now, as part of a Canary release, a decision does need to be made regarding the behavior of the Canary. If the behavior of this Canary, or our release or a change, looks good, do we want to take that and deploy it to the rest of production or to all of our users? To help facilitate this decision making, we do need to collect metrics that describe the behavior of the system. Now, these metrics do need to be tagged or namespaced in a way such that we can easily retrieve them after the fact. So you can think of this as making sure that when we report metrics, that we report metrics independently for the Canary and for, say, our production service, so we can visualize or do some analysis later with them. So once we have a set of metrics that have been collected, a decision is usually made by looking at graphs and dashboards manually and trying to decide, does the Canary look good? And you can kind of think of this as a game of spot the differences, where you're looking at the behavior of the canary as determined by these set of metrics in relation to that production system. And you're really trying to determine if the behavior of that canary is significantly different than the production system. Then based on that decision, you may decide to deploy that change or that canary to all of your users or to the rest of your production environment. However, this manual process of looking at graphs and dashboards can be error prone. It does require subjective assessment and is prone to human bias and errors. So I may look at a canary result or the results of a canary and decide it looks good. But Matt may come along and based on his experience, he may look at that and say, things are okay, let's push to production. So in addition, this process of manually looking at graphs and dashboard is time consuming. Having someone look at all the graphs or results just doesn't scale. And as you move towards more frequent and rapid deployments, having someone there to gate every deployment is not so feasible. And then finally, it can be very difficult to assess the quality of the canary in relation to the production cluster or the production deployment. The canary is not serving the same amount of traffic or doing the same type of workload as production. And this makes it very difficult to compare the canary to production and get a good sense of the behavior. And to address these issues, we can enhance the canary release process in primarily two ways. First, we can introduce an independent baseline group or server group as part of the canary release process. And so the baseline here is going to be running the same version or configuration as production. So in our diagram here, it's going to be running, say, version 1. At the same time, we're going to create the new canary version as well. And this is going to be version 2. Now, the baseline and canary are going to both be, say, one server or one instance. And they're both going to serve the exact same amount of traffic. So for example, if the canary is serving 5% of our traffic and is one server, our baseline is also going to be one server and serving 5% of our traffic. Now, it's important to remember that these clusters or these server groups are going to be serving a very small percentage of our traffic. And again, this is to limit the blast radius that any type of change can have on our end users. Now, once we have this environment set up, we can compare apples to apples. We can now compare the canary directly to the baseline and make some type of automated decision. And this is where Kayenta comes in. It's a platform for doing automated canary analysis. So Michael will now come up and talk a little bit about Kayenta and how it integrates with Spinnaker.
Thank you, Chris. Kayenta is our open source platform to allow Canary Analysis to add to a pipeline within Spinnaker. Spinnaker is our open source deployment platform built jointly between Netflix and Google. These are all open sourced, and we have a strong community around Spinnaker already, and we're intending to build a strong community around Kayenta, especially around adding new judges and new metric data sources. Spinnaker's role is to set up the canary such that Kayenta can perform judgments on that data. For example, here we have a baseline which is running exactly the same production code or configuration that the main production system is running, and the canary is running the new change. It could be a configuration change or it could be a code change. And Spinnaker will call upon Kayenta one or more times during some time window to perform judgments on how healthy that canary is in relation to the other. How traffic is actually routed is somewhat application specific. One common example, which we'll show later, is a load balancer, which is simply however many instances are available, each one gets a certain percentage of traffic. But in some situations, you may have to choose a more complicated approach where you send 1% or some small amount of traffic to your canary and baseline. The pipeline, this is a simplified version of a pipeline. In this case, we have Spinnaker deploying the canary and the baseline, and then calling upon Kayenta one or more times to get the individual scores. In this example, we have 3 scores, in this case 90, 92, and 95. Those could be in different regions, different locations, New York and California. They could also be across multiple time windows. A very common scenario is to deploy for a 4-hour canary and have 30-minute intervals. So we wait a small period to let things warm up, and then every 30 minutes after that, we perform a canary analysis. Based upon the result of that score, Spinnaker will decide whether or not it should continue deployment to production or roll that back and cancel the canary operation. When Kayenta is actually performing each analysis, this is the following the steps it takes. It will gather the metrics for both the baseline and the canary for each metric that's defined in the configuration file. That's why it's important that we can separate those out, and they have to be tagged properly so we know, is this a canary metric or is this a baseline or production metric? We'll validate that we got the data that we expected, align the data together so that the similar metrics from baseline and canary line up. We'll then perform some cleaning, make certain the data is easy to compare each individual metric as either a pass, a fail, and a fail can be either high or low, and you can override which direction you're sensitive to, so you can choose high is okay, low is okay. And finally, an individual score is computed. And this individual score is a snapshot in time. This is what the canary looked like at this moment. When you do a 4-hour window and multiple canaries, you expect each one to pass, and there's a lower threshold at which we'll cancel and an upper threshold at the end at which we'll accept. So here to give a demo is Matt.
Thanks, Michael. We'll just have to navigate to the other tabs to do the demo. We're going to do a live demo, so fingers crossed. All right, so just to give you an idea of what you're going to see, we're going to start with a quick high-level overview of Spinnaker. We assume some viewers potentially haven't interacted with the Spinnaker user interface before, may not be very familiar with it, so we'll introduce some of the more important topics. And then we'll work through the full process from beginning to end of defining a canary configuration, figuring out which metrics to use, how to apply this to a set of release pipelines. We'll walk through the configuration of those pipelines. And then we'll kick everything off by pushing some changes, which we'll show in detail, and then interact with the results, poke around the reports, and so on. So what we're viewing now is a clusters view. Think of this as the operational pane or operational view of Spinnaker. It shows all of the various resources we have under management. In this case, we're managing things deployed to Kubernetes. So represented on the screen now are 4 individual deployments spread across 2 namespaces, a production and a staging namespace. And this is a sample application just for the purposes of this demo. There's a front-end component, a back-end component, and they constitute a very simple web application. The details of it, it's written in Go, but they're not that significant. But the important thing to keep in mind here, there are 4 deployments. They're already running, some in production, some in staging. It's a pair of front-end, back-end in each. So one thing to note as we look here, I've highlighted this deployment. You can see the details and the view on the right-hand side, and you can see each of these little individual green chiclets. These represent pods. And this is the most important thing to note at the moment, where it says V14. This is associated with the 14th revision of that deployment within Kubernetes. We have the revision history set to 0, so you won't see the older ones as they're scaled down to 0. They'll be destroyed. But the idea is to keep in mind that revision, because as we work through the release process, you'll see that revision is going to roll forward and 15 will show up. Okay, so this is the automation view, the operational view. The pipeline configuration is the automation view, which we're going to come to in a moment. And remember, our goal here is we're going to experiment with pre-configured pipelines that use the automated Canary Analysis service. So before we configure the automated Canary Analysis stage within any pipelines, we need to have some Canary configurations available. So that's the next view that we're going to experiment with. So I believe Chris touched on this, or will in a moment. One of the ideas is to co-locate the configurations for the automated Canary Analysis runs with the applications themselves. This is tweakable. You can have it so that your Canary configurations can be used across all applications or are scoped to a set of applications. But the primary goal is that the operators of these systems want to have their Canary configurations close by to the services and applications that they're using those Canary Analysis configurations with. So there's a full user interface with capabilities for editing these things and managing them over time. They're all persisted along with the other artifacts of Spinnaker. So in this case, we're deploying to Kubernetes, and we're using Stackdriver to monitor those resources. I would consider it a prerequisite of using any of this that all of your systems are properly instrumented. So if you're not instrumenting your applications and your infrastructure, there's no way you'll be able to select appropriate metrics later on for use in the Canary Analysis. In this case, we selected 3 very simple metrics. You can see them down below. We'll just show the configuration of one of them. So we're looking at the CPU request utilization for containers. Again, it's on Kubernetes. We give it a name. We're using this thing we call custom filter template. And the idea here is that you can use some of the out-of-the-box capabilities for building the queries, or you can customize it any way you like. It really depends on your use case. The most important thing touches on something that Michael said, which is that you must know, in order to use this system, how to segment your data. If you can't clearly identify which data was collected or which metrics were collected from your baseline and which metrics were collected from your Canary, you won't be able to run the analysis and compare the aggregated results of each. So we have this canary configuration, it has a name, and now we're going to go over to the pipeline view, and we're going to interact with the pipeline configuration and select this canary config for use as part of a rollout. Okay, so this is a fairly typical setup. There are 3 pipelines. First one is deploy to staging, then we have deploy with automated canary analysis, and then promote canary to production. The goal of the first pipeline is to be triggered whenever any push that's relevant to this deployment is picked up. So that could be a change to one of the underlying containers. That could be a change to a manifest. In this particular case, we've configured this pipeline to kick off whenever front end or back end container images are changed, or when either of the manifests associated with those deployments are changed. We won't go step by step through the configuration, but it's important to know that's how it's kicked off because we're going to push a change, and it makes sense to know where that's coming from. So if we look deeper into the pipeline, we then see 2 parallel deployments. It's going to deploy front end and back end, but each of them are going to staging. At this point, we're not doing any canarying. The goal here is to show how we integrate a canary release into this process. So we deploy front end and back end to staging. We run some simple acceptance tests over the back end, which in this case really amounts to a Kubernetes job running a curl command against the internal backend service in whichever namespace it's in, which in this case will be staging. And lastly, a manual judgment. And all that manual judgment is for is, in this case, a human to say, I'm happy with how it worked out in staging, I'm ready to promote it into production. So I'm going to kick this off, and then we'll come back and look at the other configurations. So what we've done here is make a very simple change to the manifest that backs the back-end deployment. We've dramatically restricted the resource allocation for CPU for the back-end so that when we collect the metrics for CPU utilization, it should go up quite a bit from baseline to canary. So it has 1/20th of the allocation of the baseline. So we'll push this change. And all this change is doing, really, this operation, is just pushing that updated manifest to a storage bucket. In this case, it's GCS. And this pipeline is configured to listen for pub sub events. So we see it already kicked off an instance of that workflow. We would expect the front end to complete quite quickly. Kubernetes is smart enough to detect if it's really a no-op push, which in this case we didn't change the front end. It'll complete quicker than the back end, right? So the back end will take a moment. It is updating that manifest. So we should see this, obviously that revision should roll forward. And there's the new one, 15, and then you'll see 14 will slowly go away over time. If we had left the revision history set to anything higher than 0 for that deployment, you would see the old revision would remain, even though it would have 0 pods. In this case, it will go away over time. So we let that carry on with its work. We'll go back to the pipelines view. It's deploying. It'll take a moment. And what's going to happen next? I'll show you the configuration while we wait. Actually, it's going pretty quickly. So we have the next pipeline, this deploy with automated canary analysis. This pipeline is not configured to listen for changes to the manifests or the container images. Its configuration just has it listening for a pipeline to complete successfully, and it's that deploy to staging pipeline. It will inherit all of the artifact information, so it'll know what images were deployed, it'll know what manifests were deployed, and it can use all that information in its execution, but it's not listening for changes to them. It only waits for that parent pipeline to complete. And then what it does is, again, we see this parallel deploy scheme. It's going to, again, deploy those images and manifests that are under test, front end and back end. Only in this case, instead of deploying to staging, it's going to deploy into production. Then it's going to run the canary analysis. So let's just OK this manual judgment, and then we will we'll carry on with looking at that configuration. So we'll give that a moment. While that's thinking, let's look at our cluster setup. So remember for the next step that each of the existing deployments have 5 pods. Because as Chris and Michael both touched on, when you do your canarying, you want to do it with a smaller percentage of traffic. This is a demo. It's dramatically simplified. We're not deploying another baseline. We're actually comparing the canary to the existing baseline, which is not ideal. You want to restrict the amount of traffic the canary takes, though. In this case, well, we have 5 existing pods. We're going to end up deploying canaries that have 1 pod each. It's going to end up taking 1/6 of the traffic, which is a bit, but it's a demo. So let's look at the configuration. It's doing the deployments now. But let's look at this canary analysis stage. So it's pretty straightforward. There are not an enormous amount of configuration options here at the moment, but the most important setting is right at the top, and it lets you choose either real-time or retrospective. If this were not a demo and we weren't doing this cooking show style, we would do real-time. The deployments would happen, and then we would wait. We would give it a warm-up period. We would wait, let's say, 20 minutes, and then maybe do 4 canaries over the course of 2 hours, and each one would be a 30-minute canary analysis run. So that would be real time. But we're doing retrospective because we don't want to wait. Most of the settings are the same, except instead of waiting and then breaking it into pieces, you encode the timestamps directly within the Canary stage configuration. So we're using some timestamps from data we collected earlier in the day. Other than that, it looks exactly as the real-time setup would. So you see here we have location for baseline and Canary. We just give the namespace for each of those. And then you have baseline and Canary scope. So the baseline, well, we just want the primary. This is, as we said, it's just the baseline deployment for the backend component. For Canary, we want backend Canary. In the case of this configuration, this is how we're segmenting the data. We're using a naming scheme and some labels and things like that. This depends on your use case. There are lots of different ways to do this, especially with Kubernetes. The most common case is just to assign labels that let you identify where the metrics were collected from. So it's really use case dependent. This is just one path. We say what it is we're examining, they're Kubernetes containers. Then we get down to these scoring thresholds. I don't think we touched on these with the Canary configuration, but as you decide which metrics you want to query as part of your Canary configuration, you can group them together and then assign weights to those groups, and all of that is built up into a resulting confidence score for a given Canary analysis run. But as a given run can contain multiple intervals, we allow you to specify this threshold called marginal. And where this is used is that as each interval run is completed, if the confidence score is below the marginal threshold, it just pulls a plug. It says, pull the ripcord, we're going to punch out now, we're not going to do the future runs, don't pay the cost. So long as all those interval runs are above the marginal threshold, it will carry on and do all of the future intervals. Where the pass threshold is used is for the final confidence score. So the score returned from the final interval of the Canary analysis runs. As long as it's above pass, that Canary stage is considered a success. If it's below, it's considered a failure. As with all Spinnaker stages, there are a host of configuration options about what to do in the case of a failure. Do you halt the whole pipeline, just this branch? Do you ignore it? And so on. So it's highly configurable. All right, so in this case, it's hard to read, I know, but we have a 1 hour duration between start time and end time, and we set the interval to 30 minutes, so it's going to result in 2 Canary analysis runs, and we set the lookback type to growing, and what this means is that you'll see a run with 30 minutes of data, and then a run with 60 minutes of data. You could do sliding as an alternative. As we get into this, and we'll talk more about this in a moment, but the goal of retrospective analysis, while it's sweet to use for demos, the real goal is to allow you later on to do further experimentation, refine your Canary analysis setup, and experiment with different types of judging, different metric stores, different precisions with the metrics you're collecting, and so on. So if we go back to our view, well, it did the deployment here. So remember, we said here, yep, we're happy. We want to deploy the Canary to production. It does the deployment of the front end to production, the back end, and then it does the Canary analysis runs. And then you see it did the 2 runs. So you can see duration is 30 minutes, duration is 1 hour. It'll show you the timestamps here. And there's this nifty copy to clipboard thing if you want to do a retrospective analysis using those values. But really what we want to get to is the report. So if we click on this report, and all these UIs are brand new. It's something we're really proud of. Dan Peach on our team here at Google worked with a fellow named Scott from Netflix to build out all these UIs from scratch, including the configuration, the reporting, all of it. It's really great. We're pretty pleased with it. So you can see here, these are the 3 metrics we configured in that Canary config we looked at earlier. And one of them is high, the other 2 are pass. We didn't do anything fancy with the weights, so you can see just based on that confidence score, obviously it's 2/3 because 2 passed and 1 failed, and they're equally weighted by default. But here you can see blue is Canary, baseline is this other color, which I think is copper. I'm not sure what color that is. But you can see the CPU utilization for that given metric was obviously much higher because we really constrained the resource allocation for CPU of that deployment. So what we've seen here, besides the quick kind of 15-second blast of this is Spinnaker, is what the clusters look like, which are deployments because we're on Kubernetes here, how to navigate the operational view of Spinnaker, how to configure your pipelines to use the Canary configurations that you can curate directly within the user interface. Then we pushed a change, which was a modified manifest. We pushed to a GCS bucket. Pub sub event triggered that first pipeline. It did the deployments. It did the simple test. We said, yep, we're OK. Push the canaries into production. It pushed the canaries. It ran the analysis. If you look at what was pushed, this is pretty cool in that if you look at, well, look at the production environment for backend. There are 5 pods. And then if you look at backend Canary, there's 1 pod. That's how it's getting that small amount of traffic. And lastly, before I turn it back over to Chris, there is another pipeline here that's configured to run on successful completion of deploy with automated Canary analysis. And this is really the promotion pipeline. If this runs, all it really does is provision the new deployments, scale them up to full capacity, and destroy all the canaries and do some cleanup. One last thing, that canary analysis stage we showed is quite simple and right now focuses exclusively on configuring the analysis runs. But we're in the process of building out full provisioning capabilities within the stage itself, so you can employ the best practice that Michael and Chris described, where as part of your canary analysis, you provision a new baseline, a new canary, and you compare apples to apples, and then do all the cleanup afterwards, and there are all sorts of options associated with that. So that's in progress. Now you've seen how to use this. Next up is Chris, and he's going to give you some things to keep in mind, practical considerations as you deploy this in your own environment.
Great. Thank you very much, Matt. So we have been using automated canary analysis at Netflix for well over 4 years and realizing the benefits of this style of deployment. And over these years, we have learned many lessons about canary analysis, and a few of those we hope to share with you here today. Now, something I do want to emphasize is that canary analysis is a very iterative process that does need to be refined over time for, say, each of your applications. As your applications evolve, you make changes, you add new features, your canary release process and your configuration that goes along with it is also going to change and evolve as well. So for example, let's say that you're going to be using some new hardware or some new infrastructure for your application. This may also change the metrics or the way that you perform a canary, and this is going to need to be iterated on as well. Now, this is particularly true about the metrics which are used to assess or judge the canary as well. And so we want to select metrics that describe the behavior of the system. And this is important for the success of automated canary analysis. Now, the power of automated canary analysis comes from, one, the setup of the infrastructure, so creating that baseline of canary groups, but also comes from those metrics and how we analyze them. And so picking those metrics will take time to get right, but is a very important step to realizing the benefit of this approach and gaining trust in your deployments. And so, for example, if your canary is always showing differences as compared to your production cluster, based on some set of metrics you selected, you may lose trust in the system over time. And it may lead to more time for you to investigate and will reduce your deployment cadence and velocity. Therefore, you will need to refine these metrics over time and to make them very important to your application and to your release process in general. And this is why, as part of our work with Kayenta, we did integrate the metric configuration and the canary configuration right into Spinnaker alongside with your applications. And Matt had showed a little bit of this in his demo. Our goal was to make it as easy as possible to find, update, and manage those types of canary configurations and metrics definition. For example, in the screenshot we see here, we have a set of metrics which we are defining, and they're in, say, one group called Group 1 here. And we want to make these reside alongside the application. In this case, it's just an example called My App. But we can say I have multiple canary configurations here, example, config, and test. And we want to put these right along with the application to make them easier to find, but also to allow people to come in and modify and update them along with the rest of their continuous integration or continuous delivery pipelines. Now, there are a few best practices that you can follow when trying to select these metrics for automated canary analysis. And so, for example, sparse metrics, which rarely report any type of signals, are not real good candidates for canary analysis. And this is because of the low reporting interval of these metrics. It will be a little hard to analyze. Now, in contrast to this, certain types of error metrics make good candidate signals as they are very clear indicators of failure. These metrics can be very easy to analyze and reason about. For example, if you're looking at an increase in error rates for an HTTP server, then it is a very clear indication of failure if your canary has a higher rate of these types of errors. And we can see that in the graph on the right here. And finally, metrics which relate to application configuration may not be a good signal for canary analysis. For example, let's say you're looking at the max number of configured threads for your application. This is not necessarily going to be a good indicator of failure, as in the face of a failure, the Canary baseline will most likely show the same result. And so these aren't contributing anything to your Canary analysis and will want to be removed or tweaked for your analysis. Now, in addition to picking the right metrics, which is very important, there are also some other practical considerations to keep in mind or think about as you employ Canary analysis. And for example, when an application does start up, it may throw more errors or have higher utilization. And this can be because of caches failing, getting warm. It can also be because of garbage collection or the application establishing connections to, say, downstreams or upstreams. Now, these types of startup effects will skew the results of Canary analysis. And for this reason, you'll want to ignore these types of startup effects as part of your Canary release. And so within Spinnaker and within Kayenta, we allow you to configure a warm-up period. And for example, we can see that we're, in this example, setting a warm-up period of 10 minutes. In this example, we're going to ignore the first 10 minutes of the metrics and then perform the analysis. This will give you a little bit better confidence in your data and in the Canary release process. And finally, you'll want to consider how big to make your Canary deployment or how much traffic your Canary release is going to take. So in this example we have here, our Canary deployment is going to be taking 25% of our traffic. This example is the traffic is routed based on a load balancer. So this means that 25% of our traffic is at risk of this new change or this Canary we are releasing. Now this is contrary to the idea that a Canary is about reducing risk. And so there are some balances or trade-offs you'll have to make in terms of how big to make the Canary or how small to make the Canary. And so in this example here, we may want to use a smaller number of servers. Maybe we use only one server for the Canary, or find a different way for our traffic to make its way to the Canary. You can also debate, should we even use a Canary in this case? Let's say that my application is one instance or one server. A Canary may not be the right tool to use in this case to mitigate that risk of a change. So up next, Steven's going to talk a little bit how you can get started with Spinnaker and Kayenta.
Hi, I'll point you in a couple of directions by which you can get started on your journey to doing Canary analysis-based rollouts on your project or in your organizations. First, you need to install Spinnaker. Down below on the screen, there's spinnaker.io, our website, /setup. There are a number of ways that you can go to install Spinnaker on various different platforms and different configurations. And there you can get all the information you need to get Spinnaker installed. For those of you who have already installed Spinnaker and are running Spinnaker, obviously this is a no-op for you. Second, you need to enable Kayenta. And once again, on spinnaker.io /setup/canary, you'll find detailed instructions for setup and guides for how you can get Kayenta Canary analysis set up on your Spinnaker instance. And third, aside from directly Spinnaker or Kayenta related, you need to ensure that your applications and your infrastructure metrics are being reported to your metric store so that Kayenta can then act on those. So after the base setups are done on the top row, on the bottom row is about you starting on your journey that Chris mentioned of figuring out what are the right metrics for your particular situation and that iterative refining and ongoing process of improving your Canary signals. So number one, identifying the metrics that are strong indicators of safety for your particular application and infrastructure among the set that you set up on the previous step of infrastructure application metrics being collected. And then finally, configure your Canaries. And once again, as Chris mentioned, this is going to be an iterative and continued process for you to go do so. We're very proud of the collaborative good work that we've done here. Thanks for joining us. We want to continue, ask you to continue, invite you to continue to join us by joining in on the community on Slack, on join.spinnaker.io, where you can go and reach us with any questions or for help. There's plenty of documentation, as I mentioned, on our main website, spinnaker.io. And then, of course, we also welcome contributors, whether they are bug fixes, small features, or large things, such as adding an entire metric store. Our project is open source, and you can find our code on GitHub at /spinnaker/Kayenta. So stay tuned for live Q&A next. We'll be back in under a minute.
Welcome back. All right, we're going to do some Q&A. So these are questions from the audience, and I'll lead off with the first question. Is it possible to override the result of the automated Canary analysis? What if I need to deploy even if the system thinks the Canary failed? Yeah, so there are a couple of answers to this. Yep, so it's pretty straightforward to override the result. Spinnaker itself, nothing specific to Kayenta, supports the ability to have both conditional stages and branch operations, and you can use expressions in those conditions. So you can very easily do one thing if the analysis passed, one if it failed, and join those back up in a manual judgment. So that's fairly straightforward to configure. More importantly, if you're noticing that folks are overriding the decision of the Canary analysis often, you might want to revisit that actual configuration, see if it needs to be refined, because it probably is a signal that folks lack trust in the Canary analysis. Maybe it's the wrong metrics. Maybe it runs for too short of a period of time. There could be some reason why you need to actually address the root cause and not just override the decision and move on. All right. I think we can both do the next one. So I'll read the question. What's next for Kayenta? Could you give some details on how the automatic optimization process could work and why we would want to do that? You want to lead off and then
Sure. So
comments as well.
So what's next for Kayenta? There's a few avenues that we're exploring for the future of Kayenta that relates more to the analysis side of things. I'll let Matt talk a little bit more of the infrastructure and the Spinnaker work after myself. And so some of the work we're doing for Kayenta and where we want to expand and move towards is making our results a little bit more practical. So right now we see a lot of sensitivity in our approach, and some of the metric classifications or metric results we give are not necessarily as practical as our end users would like. So we want to spend some time to revisit kind of how do we make our results a little bit more practical for our end users to consume. The idea is to reduce risk. We also want to make these results practical and something that you can use to gain safety in your deployments. In addition, as described through the demo and throughout the presentation, Kayenta is very much a mini batch or micro batch system where over some period of time we're performing little batches of analysis over time. We'd like to investigate or move more towards a continuous evaluation approach where we're continually evaluating over an entire period of time, say every minute, generating a score. This allows us potentially to fail even faster. So if you look at a Canary deployment, we look at the risk is the greatest in the first hour, the first 30 minutes, or the first 15 minutes. And so finding those failures or those issues faster is very critical to this system managing that risk. And so we want to work at failing faster and finding those big differences and those big impactful changes sooner. And this will help mitigate the risk and be able to roll your deployments back faster.
Great, thanks. Okay, in terms of what's next for Kayenta, I can give some information on what's next for the project itself. We've made all this available. It works quite well. We're very happy with the current state of things. Now we'd really like to focus on adoption, making it easy for folks to get up and running. We have quite a bit of documentation, but we'd like more, obviously. We want to build out code labs, potentially a workshop, and most importantly, we want to grow the community. We have support at the moment for Stackdriver, Atlas, Prometheus, and Datadog. The Datadog support was added by Armory. We'd like to repeat that process, have other active participants in the Spinnaker community add support for additional metric stores. There's a pretty well-defined path for adding support for additional metric stores. We have a development guide, and we have very easy to follow commits that explain step by step how to add support for new systems or add new integrations. And in addition, we built Kayenta from scratch to be easy to develop within. So everything is exposed. There are troubleshooting endpoints. Everything is swaggered. It's pretty well documented. So it's a pretty straightforward process. It's not trivial, but it's definitely doable, and it's quite straightforward.
I think what also is next is more engagement from the community and getting everyone else involved in it, contributing, and also expanding our documentation and our best practices. We want to be able to bundle in best practices with Kayenta, so whether that includes example configurations of metrics or example pipelines. That's also in terms of getting feedback from you, the people out there wanting to use it, and iterating on that as well.
Yeah, we had talked a couple times about maybe making it smarter in terms of suggesting optimizations to Canary configurations or even proposing Canary configurations. When there was an issue that a human responded to, maybe the human could come back and say, for this release, for this scope, so these time boundaries with these resources, what sort of Canary process would have caught this, would have sussed out that there's a problem and said, this is not a safe deployment. So we think we can get smarter about that over time and really not leave folks with blank screens where they have to figure out all this configuration from scratch. All right, so the next question is documentation mentions real-time and retrospective evaluation. Can you give some pointers regarding which to use when? All right, I'll lead off and jump in if you want to add something. So real-time, we touched on it a bit. The idea is as part of a release pipeline, you provision the resources, and then you want to compare the metrics being collected from those resources you just provisioned. So you would have typically a warm-up period, and then for both the newly provisioned baseline and production and Canary deployments, you would compare those metrics to one another in real time, meaning the metrics collected over the last hour, 2 hours, 3 hours. Retrospective is similar for all of the configuration with the exception of the timing information. Instead of saying start now, wait this period of time, and then do these intervals, it says for these given encoded timestamps, do the analysis. You can still do it in intervals, but it refers to past points in time. The benefit of this, besides being much easier to demo, is that you can experiment with different configurations. So different judges, different metric stores, more precise, less precise data, more metrics, less metrics, and so on. All right, I think the next one's probably yours.
So can you talk a little bit about your experience with optimizing Canary Analysis for applications? What would your top 3 lessons, bits of advice be? It's a good question. Much like the practical considerations is, I think one of the big lessons to take away is that the metrics matter. Is the signals you put into the system are going to be very important to the success of Canary Analysis. Kind of the idea of garbage in, garbage out. If you give it bad metrics, you potentially get bad results. And so there is this iterative process of taking your Canary release and iterating on those metrics and finding the right signals that are going to be successful for doing a Canary analysis. And kind of piggybacking off that idea of putting the right metrics into the system is making sure that your infrastructure is set up correctly. For example, making sure that that baseline and that Canary are both running in the production in the same region, taking the same amount of traffic. The experimental setup or the infrastructure setup is very crucial to making Canary analysis a success. And so having that combination of a good setup and a good experimental setup, the right metrics, really alleviates a lot of the issues with downstream Canary analysis with why did this fail or why did I see a difference. So focusing on kind of the setup and the metrics can alleviate a lot of those problems down the road.
Yeah, this is a really great point. If you can't, absent Spinnaker and Kayenta, clearly identify how to segment, like along what dimension to segment the metrics that you've collected, you won't be able to perform the analysis. Kayenta isn't going to magically discern the difference between metrics you've collected. You have to be able to collect them, identify the 2 groups of metrics that you've collected that you want to compare. That's what the judge considers when it's performing its analysis. So that's a great point.
So with that, I think we're out of time.
Yeah. Continue to look for answers to your questions. Folks will be answering those in the setup after the webinar ends. Thanks everybody for your time. Stay tuned for the next session, Build Modern Apps Using an API First Strategy.